presentation at Innovators Corner will be by Mr. Ventimiglia from TARDEC, and it'll be on situational awareness and active countermeasures for the soldier ground vehicle systems using quad rotors.
All right, thank you, everyone. My name is Dean Ventimiglia, and I'm here from the Tank Automotive Research Development and Engineering Center, and I am here to speak to you about a program that we call SQUAD. SQUAD is a joint services program. It was funded as a seedling program using the Office of Secretary of Defense, and it is between the Army and the Navy. It also has multiple Army partnerships, including CERDEC, ARDEC, TARDEC as the lead, SPAWAR, and AMRDEC. And this program had 5 primary objectives to it. We wanted to enable takeoff and landing from a moving vehicle. We wanted to ensure that we could come up with algorithms to detect unmanned aerial systems. We wanted to make sure that we could actually search an area effectively and make sure that if we had multiple assets that they had collision avoidance technology. We also wanted to make sure that once we had identified the unmanned aerial systems, that we had a common counter-UAS capability. This program was condensed into approximately 18 months, so we wanted to find out how we could effectively take capability using common off-the-shelf rotorcraft and provide capability to the Army. So the first thing that we wanted to do was we wanted to ensure that we did not have the same problems that currently are in the field. Right now, what soldiers need to do is when they launch the unmanned aerial systems, they have to dismount. They have to become actually exposed to small enemy fire. So we thought, why don't we put this into a system where we could put it on the back of a vehicle and actually launch the vehicle remotely and not actually expose the soldiers to that threat. So TARDEC actually led the effort to develop this container that is protected from both the element and small enemy fire and make sure that the soldiers were still buttoned up inside their vehicle. The next capability that we wanted to provide was to look at what happens when we want to search or have a recon of a specific area using multiple assets. So as most people know, one of the limiting factors for any UAS is the flight time, and that is because of battery power, and that is determined both on the environment, if it has wind, or if it is a perfect day, as well as what the payload is for the actual system. So using multiple UASs, we worked with our partners, U of M, and came up with an algorithm to effectively search an area using the least amount of energy possible so that we could either cover a larger area or to ensure that we could cover the area that we wanted, while also making it recoverable. One of the problems that you might encounter whenever you have multiple assets in the area is that they might actually collide with each other. Part of the program was also to make sure that we provided collision avoidance. So that was accomplished through the algorithms and also to make sure that they didn't run into one another. And finally, you will see on the top a small shadow. What we wanted to do is we wanted to actually be able to detect drones using our asset. So you'll see a small shadow run across the top screen. That's pretty hard to see, especially more difficult if it's a cluttered environment. So what we did was we worked with SPAWAR, and they developed the capability down in the bottom left to be able to detect the UAV. You'll see 2 shadows now, a small shadow as well as a blue blip. So what that shows is we can actually filter it and we can more effectively find the UAS. The only thing you were able to find in the unfiltered was the shadow of the actual UAS. You were not able to actually detect it. So now we're able to target it track it, target it, and provide software capability through our partnership with AMRDEC to be able to have a counter UAS engagement. That is the end of my presentation. I am open to any and all questions.
So you got a system by which you launch the quadcopter.
Correct.
How do you recover it?
So the recovery, it depends on the radar and the ability that you have. There are two methods to do it. It's really tough when it's on a moving target. But if you have the proper sensor and if you have the proper sensor both on the vehicle, so it's actually sending up a signal. So it's almost like a homing. It will come back to the system. You also have the capability, if that's not available, or if it's running low on power, you can actually direct it to a specific area that might be now a protected area that you can drive up to, drop the ramp, it's protected, now the soldiers can recover it manually if needed.
Okay, that's what I was. So the soldiers still sort of have to get out to recover it.
They would in specific instances, but the intention was to actually have it so that it would come back and go back into the actual container.
Have you been successful at doing that?
We did, but in a limited fashion. Any other questions? More? All right, thank you very much. You all have a wonderful